right? And this is the variable that we're measuring, right? It's like if you're doing a science experiment, for instance, right? You're measuring something, if you do uh let's say you're looking at a pendulum, right? You're looking at how a pendulum moves, and you vary the length of the string of the pendulum, or you vary the mass of the pendulum bob, right? And then you look at how let's say how far the pendulum moves from its starting position, right? If you have some sort of pendulum like this, right? Let's say you have some length that's originally 10 meters or 10 centimeters, and then you make it 15 centimeters, and you make it 20 centimeters, and so on. You keep changing the length of this thing, maybe up to 30 centimeters, right? And and then and then you release the pendulum from some angle, right? You release pendulum, and the pendulum will swing, right? It'll swing. So in that case, what we're measuring is, how far the pendulum swings, or how fast the pendulum swings, or whatever you want to measure, right? Or how long it's swinging for before it comes to a rest, right? Before it stops swinging. So there are many things you can measure. So that's basically a dependent variable, right? And that's y, what y represents. X is what we're changing, right? It's the independent variable. So in this case, we're changing the length of the string. We're changing the length of the string to see how that affects some aspect of the motion of the pendulum. Doesn't matter what aspect it is. We have some dependent variable and we have some independent variable, right? So that's a very broad level picture of what these terms mean, what dependent and independent variables mean. And now, I mean, in some cases, we can put it in a more mathematical form, right? So this is basically the form that it takes. This is the form of a straight line. So when we draw the axes like this, right, the black axis that you can see here, when we draw that, right, this is y, and this is x, right? And what you do is you say, okay, when I change x, I want y to change in some way. That's what any science experiment also does, right? When you change the independent variable, you're expecting the dependent variable to change in some way. So in this case, you're giving a mathematical expression for that. You're saying, okay, when I change x by a certain amount, y should change by a certain amount, right? That's what linear equations do. So this is the general form, and this m over here is called the slope, right? Have you seen, have you heard about the concept of slope before?
Yeah, the gradient.
The gradient, exactly, right? So that's what this m represents, and b is called the y-intercept. And the y-intercept is basically value of y when x equals 0. Right? So basically what can happen is your x-intercept could be anywhere on this line, right? It could be anywhere here. Right? Yeah, it could be anywhere on that line. And you can draw the line accordingly, like that. Right? So that's basically what it is. So let's see it with an example, right? So if we have this equation, y equals 2x plus 2, this 2 represents the y-intercept. So whenever you see a linear equation, an equation of this form, right, of the form mx plus b, right, m and b are just any numbers, doesn't matter, and they could even be 0, right? They could be negative, they could be positive, any numbers, right? So when it's of the form mx plus b, you look at the b and you say, okay, whatever this value of b is, you look at that value on the y-axis and just put a dot there, right? So our value of b here is 2. And we put a dot at 2. Why do we do this? Because on the y-axis, x is equal to 0. Right? On the y-axis, x is only 0. And so what this value of b is telling us is the value of y at x equals 0. Right? So the value of y at x equals 0 is 2. So the point 0, 2 is on the line. Right? That's what that means. If the value of y at x equals 0 is 2, that means that the point 0, 2 is on the line, because x equals 0 and y equals 2. So this point is on the line. And to specify any line, you just need to know any 2 points. You know any 2 points, and you have specified exactly what the line is going to be. Right? And by specified, I mean that if you know 2 points, you just draw the line between the 2 points and you extend it, and that's your line, right? You don't need to know more than 2 points to specify a line. So in this case, all we need to do is we need to plug in another value for x, figure out the value of y at that value of x, and draw the line. So maybe let's take x equals 1, right? What's the value of y at x equals 1?
Zero?
Not quite, right? Put in x equals 1 over here. Instead of, so when I say at x equals 1, it means plug in 1 here.
Oh, so 2.
Not, you're close, but not exactly. So this would be 2, but there's this one as well, right? So it's 2x plus 2.
Oh, so if x is 1, 2 times 1, 2, add 2, 4.
Exactly, 4.
That's the value of y. Okay.
So you would draw, you would put this dot over here, and then all you would do is just connect the two, right? Just connect the 2 dots, and then extend it, right? Just take a ruler or a straight edge, and just extend here, right? Extend it like that, and that's your line, right? And I mean, I don't know if you've heard of this before, but there's only one line that passes through any 2 points, right? There can only be one line between any 2 points. This is a standard fact in geometry, and it's good to know, right? So if you have 2 points, you have specified the line exactly, because I cannot draw a different line that goes to the same 2 points, right? It's if it goes through this point, it's not going to go through this. If it goes through this, it's not going to go through this. So between any 2 points, there can only be one line. So that's basically how you draw a line. What you do is, right, you look at different values of x. You can basically draw a table. Wait, let me just yeah. Add a slide. 1 second. So okay, so did this example make sense, or I mean, do you have any doubts about it? Feel free to ask.
It makes sense. I just have a quick question. You know how we got x plus 1? How did we get that?
X. Oh, this
X equals 1. Sorry.
So I just substituted the value in. So right, so you can put in whatever value of x you want into this equation. Right. When we have an equation, y equals 2x plus 2. Right. What this is saying is, you give me a value of x, right? So give me an x, and I will give you a y. I will give you a y. That's all this is saying. This is saying I have a rule, right? This is just a rule. This is a rule.
Oh, I get it. It's like a formula kind of thing.
Exactly. It's a
Yeah,
formula.
okay.
Right. So you give me an x, I'll give you a y. So you can choose whatever value of x you want. You can take x equals 0, you can take x equals 0.25, you can take -1, whatever you want, right? Plug it in here, substitute it, and then just do the arithmetic, and then you get the value of y. Right. So what you can actually do is you can make a table. So you can say, so you can have values of x, right, and values of y. So you can say, okay, when x equals 0, what's the value of y? What's y when x equals 0?
Is it just 2?
Yeah, it's 2. At x equals 1?
4.
-1?
-2. So would it be 0?
Yes, exactly. 0. Right. And then you can take, you do a couple more. So what at x equals 2?
6.
6. And -2?
Is it -2?
Yes. Perfect. So you can actually make a table like this, right? And for each entry in the table, you have a point, 0, 2, right? This is the x and this is the y, right? That's how we represent points on the plane, right? The x coordinate and the y coordinate. From this one, you have 1, 4. From this one, you have -1, 0, right? 2, 6, -2, -2, right? You get a bunch of points like this, and then you just draw them out. So you say, okay, 0, 2 may be somewhere there, right? And then 1, 4 will be somewhere here, right? And then you have 1, 4 will be here, 0, 2 will be here, and then -1. -1, 0 will be here, right? So you see what I'm saying, right? You can then you have 2, 6, you have -2, -2. You just put these in, right? You just plot these points, and then you draw a line that goes through those points. Does that make sense?
Yeah.
Okay, great. So that's basically how you plot a straight line, right? You have an equation, y equals mx plus b. M is a slope, and what the slope is saying is this. This is what the slope is saying. Slope is saying rise over run. And what that means is, you can think of this as with mountains, right? A high slope means that it's difficult to climb the mountain, right? It's very steep slope, right? Whereas if you have right, if you like let's say a slope of like 100 or a 50, that's a very big slope, right? Your line is going to be very, very steep. It looks something like this, right? This new line that I've drawn, that's what it would look like. If you had a very, very high slope, very large slope, it would be a very steep line. Whereas if you have a small slope, like 1 or 0.5 or like 1/4, which is 0.25, right? If you had something like that, it would be a very shallow line, something like this. So what the slope is basically saying is how steep your line is, right? If you have a very large slope, then your line will be very steep, because mathematically what slope means is change in y, right? Change in y over change in x. And that's what this delta symbol means. Delta means change in. That's how we read it. Okay, when this triangle symbol that I've just drawn, right, over here. Have you seen this symbol before?
Yeah.
Yeah, right. So it just means change in, right? So change in y over change in x. So big change in y over small change in x means that you're going up really, really fast, right? You're going up for every little x that you move, you're going up really, really fast. That's what a high slope means, right? And this b, of course, means the y-intercept as we just saw. Okay, so let's move on to some examples, right? So one case where straight lines are used a lot is exchange rates, right? If you're converting from one currency to another currency, like let's say the Great British Pound to the dollar, or in this case the Kuwaiti dinar, which is this is actually the strongest currency in the world. The exchange rate with the United States dollar for the Kuwaiti dinar is the highest. So 1 KWD or Kuwaiti dinar is 3.27 United States dollars, right? I think for the pound it's something like 1.6 USD, something like that, and for the euro it's something like 1.2. This is 3.7. It's very, very strong. The Kuwaiti dinar, it's the strongest currency in the world. So in this case, when we can find an equation for this exchange rate. So this is called an exchange rate. And we can find an equation for the exchange rate, and we can actually plot the graph. And what I mean by plotting the graph is, right, we get an equation in the form y equals mx plus b, right? Where y is the Kuwaiti dinar, right, the KWD, and x is USD. So what this equation would tell us is, I will give you a value of USD, and you give me a value of KWD, right? I give you, okay, I'm going to say $5. I give you $5. If I give you $5, how many KWD should you give me? Right? That's what the equation is saying. So what would be the equation that we would form here? So think about it, give it a shot, and let me know when you have an answer.
I'm not quite sure how to work out the.
Okay, no worries. We'll go through it. So have you heard about exchange rates? Right? Have you seen them?
Yeah.
Right. So what they basically say is, how do you convert between currencies, right? Because not all currencies have the same value, so to speak, or not value, but like, you know, one unit of every currency is different, right? So like we saw, like the pound, the euro, the dinar, the US dollar, these are some of the strongest currencies in the world. And what strongest means is you compare a currency with some universal standard, and in the world today, the universal standard is the United States dollar, right? You compare currencies with the United States dollar because it's a stable currency. So when we compare currencies with the US dollar, it turns out that the Kuwaiti dinar has this exchange rate of 3.7 USD. What this means is, if I give you one Kuwaiti dinar, how many US dollars would you give me? Like as equal value, right? So if I give you one Kuwaiti dinar, how many US dollars would you give me, such that both of our, whatever you give me has the same value as what I gave you? How much would you give me? According to this equation.
Would you have to divide the 1 by the 3.27?
So that's actually the answer to this. That's actually the answer to the question that was this one, right? That's the answer for that. But if I give you one Kuwaiti dinar, you would give me 3.27 US dollars, right? If I give you one Kuwaiti dinar, that's what this is saying. One KWD equals 3.27 USD. But what he said is absolutely right. For the question that's asked in the slide, you would have to divide. You would have to do this. If I give you one United States dollar, right? If I give you $1, then in that case, you would have to give me back 1.1 over 3.27 KWD, because we have that one KWD equals 3.27 USD. So you divide and you get 1 over 3.27 KWD equals 1 USD. Right? So yeah, great job. This is basically how you solve the question on the slide. And And now how would I write the equation in this form?
Would it be y equals would it be the 0.305 then the 3.27?
So 0.305 times 3.27, or like what comes after this,
The x.
right? And then what's the value of b?
Is it the US dollar?
It's just 0.
Oh, okay.
It's 0 because like so in these cases it's very helpful to think about examples, right? What does b represent? B represents, okay, when x equals 0, what should y be, right? So if I give you $0, right, then you should not give me any Kuwaiti dinar either, right? I'm not giving you any money, so why should you give me anything in return, right? If I give you nothing at all, right, you shouldn't give me back anything either. So for any exchange rate, right, if you have 0 of that, 0 of one currency, it's equal to 0 of the other currency, right? And so 0 United States dollar is equal to 0 Kuwaiti dinar, so that's why it's 0, right? So this is basically the equation. And now let's try to graph it, right? So we have y equals 0.305 x, and right. So what's the first step? How would you start with the graphing?
Draw like the x and y coordinates and like points.
Okay, so like this.
Yeah, I guess.
Okay, and what would be the first point that we put on the plane? What's the first point that we want to? I claim that without doing any calculations at all, without entering anything in the calculator, doing nothing, we already know one point that lies on the line. What's that one point?
The 0.305.
It's so you have to give me a tuple, right? You have to give me something comma something else. So 0.305 is one number. You have to give me two numbers. You have to give me an x coordinate and a y coordinate. So what would those be?
Is one of them 0?
So okay. So, 0. So are you saying 0, 0? Or one of these is 0?
I think one of them is 0.
Okay. So which one is 0?
Is it the y?
Okay. So when y equals 0, what, right? So what would the x be? Right? A point is represented by the x and the y coordinate. So
would it just be 0 as well?
Yes. And why would it be 0 as well?
Because like if it's on 0, it's just gonna be like 0, 0.
Yes, exactly. Our b value was 0, right? You remember here, this was 0. And what we saw earlier, right? And in this example, what we saw was, right, whatever b value you have, you just put it directly on the y-axis, right? Because it's a y-intercept. And y-intercept basically means where on the y-axis does the line cross, right? The line will go through the y-axis at some point, right? This vertical line is the y-axis. Any straight line, except for any straight line actually, and any straight line except for some other vertical line, and we don't have to worry about that case. But any straight line other than a vertical line will go through the y-axis. So okay, you don't have to worry about the vertical line here. That's not really required, right? But any other straight line is going to cut the y-axis at some point. And what this b specifies is the point at which it cuts the y-axis. So from the value of b, you already know the point at which it's going to cut the y-axis. So, right, so in our case, because b was 0, it's going to cut the y-axis at 0, 0. If b was 5, it would cut the y-axis 0, 5. If b was 100, it would cut the y-axis 0, 100. Right? Does that make sense?
Yeah.
Right. So our first point is just going to be this. Okay. So we have 1 point. What's the next point? What's another point that we can find out very easily without doing much calculation?
The gradient?
Yeah, so we know the gradient, right? The gradient is 0.305. Using the gradient, what is 1 point that we can figure out very easily? Right? Try to make the table, right? The x and y table, right? We first looked at what happens when x equals 0. We already know y equals 0. So try to figure out what's another easy value for x that you can take to figure out the value of y. What's another very easy 1? Exactly. So when x equals 1, what is y?
Is it 1?
Not quite, right? Look at the equation. Y equals 0.305 x. This is our equation, right? So when x equals 1, what is y?
0.305.
Exactly. Perfect. Right? Anything times 1 is just that number, right? So in general, when you're drawing equations of lines, right? Look at what happens when x equals 0. What happens when x equals 1? These are very easy values to take. Because when x equals 0, that's just going to go to 0. Right? Anything times 0, 0. 0 kills everything. Right? It kills everything. No matter what you multiply with 0, it's going to go to 0. So whenever you're trying to figure out how to draw a line, just plug in x equals 0 and see what value you get for y. And then plug in x equals 1, right? 1 is also very easy because there's not much multiplication to do. Anything times 1 is just itself, right? 0.305 times 1 is itself. 1/4 times 1 is itself. 1,000,000,000 times 1 is itself, right? It doesn't matter what you give. You give any number times 1, that's going to give back that same number. So it's very easy to do calculations because you don't have to do big numbers. You don't have to take care of big numbers, right? So usually it's good to take x equals 0, x equals 1, find the values of y, and then plot those 2 points. So our first point was 0, 0, right? First point was 0, 0. What's the next point going to be based on what we just have in our table? What is the second point that we will put on our graph? What, comma, what?
1, 0.305.
Perfect. So that's going to be, right, if this is 1, then 0.305 is going to be somewhere over here, maybe, I don't know, right? Really low. So now what we do, we just connect the 2 lines and extend. And that's it. That's our line. Okay, so that's all you do. Right? So you have the exchange rate. Right? You see, so here we were given one Kuwaiti dinar equals 3.27 USD, but we were actually asked to do we were asked to find the equation for the opposite, right? 1 USD equals how much KWD? And what did we do? We divided by 3.27, right, to get that, in sort of inverse relationship, right? And then we got 0.305, which is equal to 1 over 3.27. We found the equation, right? We wrote y equals 0.305x, and here, of course, y represents the USD and x represents. Oh, oh, sorry, this should be USD. My bad. Yeah, okay. So Y represents USD and X represents KWD. Right, and then we do that, and then we draw the line. Right, we find the 2 points as X equals 0, X equals 1, find the values of Y for those 2 points. And then we just plot those 2 points, draw the line between them, and extend. Okay. Any questions about this?
No, it makes sense. Thank you.
Okay, great. Okay, so now we'll move on to distance time graphs. So this is a very, very typical example, especially in physics. Right? If you're taking physics, you might see this a lot. So you draw a graph of distance against time. What that means is, as time passes, how much distance have you covered? Right? Let's say you started someplace, you started your home, right? And you want to get to, let's say, the ice cream shop, right? The ice cream store. So, you start walking, right? You walk from your home to your ice cream store, and as time varies, let's say it takes you 5 minutes to get there, right? As time varies, your speed may change. You may not walk at a constant speed, right? You may stop for a signal, right? For a red light or whatever. Right? You might walk faster in some sections. So your speed time. So we can basically analyze, basically how at what rates you're moving, and that can be represented in a distance time graph. And how much distance you cover after every time step. That's what this basically represents, right? So here it is, and the graph of an object traveling at a constant speed is a straight line, right? So if you were to just travel at the same speed, if you were to walk at 5 meters per second or something, or right, or let's say you're driving a car and you're going at 60 kilometers an hour, right? If the car stays constant at 60 kilometers an hour, that's a constant speed, right? Constant speed means speed does not change. Speed does not change, right? You're going at the same speed throughout your journey, right? In that case, the distance time graph is going to be a straight line, right? Because your speed is not changing, and the gradient of a distance time graph is basically speed, right? That's what this says. The gradient of a distance time graph represents the speed at which the object is traveling. And gradient, as we know, is basically the slope, right? So if we have constant slope, that means what? Constant speed in this case, because gradient is equal to speed, right? For a distance versus time graph, gradient is equal to speed, right? So if we have if you have a straight line, right? A straight line has, the same gradient at all points. Right? You can have weird graphs like this, right? These kind of, weird graphs like this or like this, right? You can have these kind of graphs are possible, right? If you try to graph like x squared or x cubed, these kind of things, if you try to put these functions in a graph, right? Y equals x squared or y equals x cubed, or something like that, you'll get weird graphs. And those graphs do not have constant slope, right? It's steeper here, and then it gets shallow, and then it's almost horizontal at the top, right? And then it's steeper again, and then shallow again, steep again, shallow again, right? You see what I'm saying? This is kind of making sense, right? Certain graphs can have different gradients at different points, right? Does that make sense?
Yeah.
Right? So at least qualitatively, right? We don't need to look at it from a very mathematical point of view, but qualitatively, right? Looking at the picture, you can kind of see that you're very, very steep over here, you're very horizontal over here, right? And then you're steep again, and then you're horizontal again, steep again. So So these kind of graphs are possible, right? There are functions that look like this. There are graphs that look like this, right? And these do not have the same gradient at every point. Whereas a straight line has the same gradient, right? We know the equation is y equals mx plus b. And this is the gradient, right? There is only one gradient, right? When we look at straight line graphs, there is exactly one gradient, and that is the m. So at any point, that gradient is the same. At any point, the slope is the same. It's not like the slope is changing, right? It's not like it's not like a very like a weird mountain. It's a very nice mountain, and it's a mountain with the same slope. It's same slope. So basically what I'm trying to get at is when we have a distance time graph, right? We have that the slope, right, is constant, which means the slope does not change. Like the slope is the same at all points, which means we're traveling at the same speed. That's what that means. Okay, so that's basically what it is. For a distance time graph that is a straight line, the speed is constant. Okay, so let's look at this worked example that'll maybe give you a better idea. So the graph on the left represents an object traveling at constant speed, right? As you can see, it's a straight line, which means the speed is constant. So from the graph, calculate how long it took to cover a distance of 30 meters. So what you would do in this case is you'd see, okay, distance is on the y-axis, right? Time is on the x-axis. You look at distance equals 30, right? And you see, okay, right? When the distance is 30, right? Like basically you draw this horizontal line at 30 and see where it cuts the graph, right? And then you draw a vertical line downwards and see at what time. So what this is basically doing is, right, this graph is going to it's going to reach 30 meters at some time. There's some time that's going to reach 30 meters, and we don't know what at what time that is. We want to figure out that time, right? We want to figure out at what time do we reach 30 meters. For that, what do we do? Okay, we see we basically see at what time it is 30, right? And how do we do that? We draw the horizontal line 30, and we see the point that this horizontal line cuts through at the graph, right? We look at the point of intersection between this horizontal line that we've drawn and the graph that we're given. That's basically the point at which the graph has a distance value of 30, right? At that point at which this horizontal 30 line cuts our graph, at that exact point, right, we know that the distance value is 30 because we drew the horizontal line at 30, right? So we know that the y value is 30, and then the graph basically tells us what x value corresponds to that y value of 30, and in this case it's 3, right? Does that make sense? Hello, can you hear me? Hello?
I can hear you.
Oh, that's great. Hi, Ananya. Okay, I'm not sure if Zara can hear me, but okay.
Sorry, I can hear you. Yeah.
Oh, okay. Okay, great. All right. So does what I'm saying make sense, right? You draw this horizontal line, and then we look at the point at which it hits the the straight line, the graph, and then we draw this vertical line down to the x-axis to see what x value that corresponds to. Does that concept make sense? Do any of you have any questions about that?
It makes sense.
Okay, right. And now to calculate the gradient, right? Like I said, you just need 2 points. You need 2 points, and the gradient is given by, right? You take 2 points, x1, y1, and x2, y2. And the gradient is y2 minus y1 divided by x2 minus x1. And you might have seen this formula before. If you have not, then here it is, right? This is gradient. So you just do y2 minus y1. You pick any 2 points, right? In this case, what they did is they took the point 0, 0, right? Because the line passes through 0, 0. And then they took the point 4, 40, just this one, right? 4, 40. And then they use this formula. So we do 40 minus 0 divided by 4 minus 0, right? Which is 40 over 4, which is 10. That's how they obtain 10. And then to calculate the speed, right? We just saw that the gradient is equal to the speed, right? We just saw this. So the speed is just going to be 10 meters per second, right? And how did they get these units? Well, that's because the distance was given here in meters and time was given in seconds, right? So that's how you get 10 meters per second. Okay. Any questions about that?
I can't see the screen.
Oh, sorry. Sorry. Okay, can you see it now?
Yeah, thank you.
Yep, no worries. Okay, so yeah, this was the formula that I was talking about. Oops. This formula, right on the top right-hand corner. That's the formula for gradient or slope. And so yeah, that's basically how we did 2 and 3. So yeah, if you have any questions, feel free to ask. Otherwise, we can move on. All right. So here's a problem. 2 objects A and B set off from the same point and move in the same straight line. B sets off first, while A sets off 2 seconds later. Using the distance time graph on the left, estimate the speed of each of the objects, right? So part A is asking for the speed of each of the objects. So as we can see, they both start off from the same point, which means that their original distance is 0, right? They both start off when time, right? They're both starting off at distance equals 0. That's what it means, start off from the same point. But B sets off first, A sets off 2 seconds later, right? So in these 2 seconds, I mean, A hasn't started, right? A is at 0. It's like this for A. And then at time t equals 2, A starts its journey. So how will we calculate the speed of A? What would we do?
The distance over the time.
Yeah. So in this case, like what numbers will we use?
Fourteen 3.
Sorry, 43. I couldn't quite hear that. Could you please say that again?
I'm not sure, but is it 40 and 3?
Yeah, 40 and 3. Yes. 40 and 3. Correct. So you could have picked anything else. You could have also picked this one. No. Sorry, this is not correct. That's a trick. Right? It's not 40 over 3. It's not, because A is not starting at 0. Right? A is starting at 2. So when you do 40 over 3, what you're implicitly doing is 40 minus 0 over 3 minus 0, which means that the other point that you picked, so one point that you picked was 40, 3. The second point that you picked was 0, 0. But 0, 0 is not on our graph. You look at the line for A. A does not pass through 0, 0. A passes through 2, 0, not 0, 0. Right? So so we cannot take we cannot take 0, 0 as a point. So in this case, 40 minus 0 over 3 minus 0 is not quite right. So what would we do? So you take 40, 3 as 1 point. What's the other point that you want to take? You cannot take 0, 0. So what other point that lies in the graph of A can you take?
You can take 80 over 2.
So 80 and 2 or
80 and 4. No, yeah. And you would do the fraction 80 over 2.
Yeah. So you take this one, right? So that would be 80, 4, right? And then you need another point. So you have to, the other point that we can take is this one, 40, 4, 80. My bad. Right? You have to represent the x coordinate first, right? 4, 80. It's always x and then y, right? And then the other point would be 3, 40. So this is actually 3, 40, right? And then what you would do is you would actually do, so y2 minus y1, so 80 minus 40 divided by x2 minus x1, 4 minus 3. So it would be 40 divided by 1, which is 40. 40 meters per second. Does that make sense? Or should I mean, I can repeat it.
That makes sense.
Okay. So yeah, we just took 2 points. This was our x1, this was our y1, right? This was our x2, this was y2. We do y2 minus y, or sorry, this was x2, this was y2. That's fine. I mean, honestly, it doesn't matter, but just the way we did it, this was y2, this was y1, this was x2, this was x1. We did y2 minus y1, which was a numerator, and x2 minus x1, which is a denominator, and that's how we got the answer. Okay, part B. Now calculate speed of B.
We can use 340 and like 680.
Yep, you can do that. So we can do so 340, 680. That would be 80 minus 40 divided by 6 minus 3, which is 40 over 3. So in this case, it is 40 over 3. Right? And I mean, this works perfectly fine. This is totally fine. But you, in this case, you could also do 340 along with 0, 0. That's also fine. Both are okay. Right? Because the B line, right, the line for B passes through 0, 0. So essentially, you basically want to pick the easiest points that are, easy for you to calculate, right? So when you can take 0, 0, take 0, 0. That's the general, rule of thumb that you should keep in mind. Whenever you can take 0, 0, take 0, 0, and then the other point you take whatever is convenient for you. So yeah, okay, great. Okay. Now part B is asking, how far apart would the objects be 20 seconds after the start? Okay, so that's interesting. How far apart would they be 20 seconds after the starting? So how would you go about doing this? What would be the first step?
I would look at it for like 4 or 5 seconds and where they are at like 4 or 5 seconds. Personally, I would choose 4 because that's like the lines are crossing through 4. And then we can times that by 5, like both the values, and then find the difference.
Perfect. Yeah, that works. Great. So yeah, okay. Why don't you actually, both of you can go ahead and try that out and tell me what answer you get. then we'll work it out.
The other girl left like a few minutes ago, but I got like 150.
150? Okay. Okay, I'll just give a couple more minutes and then we will discuss it. Okay. So Zara, do you need a bit more time, or would you like to discuss it? Are you stuck somewhere? Feel free to ask if you have any questions.
So she left like a few minutes ago.
Oh, she did. Oh, okay, okay. Sorry, I didn't know that. Okay, my bad. All right. So 150. So okay, so what we basically do is we look at, okay, what's the value at 4? Right, so it's a bit unclear. So did you take 50 for 4 here?
Yeah, I did.
Okay, I mean, it's a reasonable estimate. You could, I guess, I don't know, maybe 52 or 54 probably be the exact amount, but it doesn't matter. If we take 50, then it is 50 times 4, which is 200. Sorry, times 5, which is 250. And then uh, for A, it's 80 times 5, which is 400, and then 150. Perfect, yeah. That's right. Okay, we've got just a couple more minutes. We can maybe try to do a few parts of this question. So 3 objects move the same straight line away from a point X. Both A and C change their speed during their journey, while B travels the same constant speed throughout. From the distance time graph, estimate the speed of the object B. Okay, go ahead and give that a try.
I got like 4/3, which is
4/3.
1.3, which is 1.3 recurring.
Right. So should be 8 minus 4 divided by 6, which is 8/6, which is 4/3. Yep. It's 1 and 1/3. Perfect. Part B. The two speeds of object A. Right? So there's one speed over here and one over here.
I got like 6 miles per second, 6 meters per second for the first like
Uh-huh.
diagonal, and for the second one I got 2.
2. It should be 8 minus 6 divided by 4 minus 1, which is 2/3.
Oh.
Wait, there's something wrong then. 1 second. Oh, this should also be 2 over 3. My bad. I made a calculation error. What did you get for the first one again?
I got 8 over 6, which is like 4 over 3. I think I did it wrong.
Yeah, so I think we made the same error with 8.
Yeah.
What you have to do is to subtract this, right? So you look at these two values, right? You look at these two values, and you do 8 minus 4 divided by 6 minus 0. Is that what you try to do?
No, I used like the distance of a time thing, but I accidentally chose 8 instead of 4, because like the difference between 8 and 4 is 4. So,
Right.
and
Okay.
I did 8 over 6.
Okay. So what you need to do is, see, you can't always do distance over time if the line doesn't pass through the origin. That's what I was explaining in the previous slide. This line doesn't go through the origin, doesn't go through 0, 0. So if it went through 0, 0, then you would be able to do that, right? If we had a line like this, in that case, the speed would indeed be 8 over, so in that case, it would be 8 over 6. Okay. But our line doesn't pass through the origin. Our line hits the y-axis at this point, right? So we cannot do we cannot do 8 over 6, because 8 over 6 is like doing 8 minus 0 over 6 minus 0, which means we are picking 0, 0 as the second point on our line, but 0, 0 isn't even on the line, so we cannot pick it. Does that make sense?
Yeah.
Yeah. So you have to take 6, 8 and 0, 4 instead of 0, 0. So that's basically what we do here. And in part B, so this 6 meters per second is correct because this first line does pass through the origin. For the second one, it's 2 over 3 again, because I picked the point 4, 8 and 1, 6, right? So 8 minus 6 over 4 minus 1, that's 2 over 3.
Okay.
Okay. All right. So I think we will stop here. So yeah, I hope that you enjoyed that session, and yeah, we'll meet again next week. Have a great weekend.
Okay, thank you.
You're welcome. Bye.